Okay, so section 5.3 is titled Interpreting and Sketching Graphs. We are eventually going to be doing a graphing assignment in which we'll sketch a number of different graphs. And interpreting graphs is a fancy way to say looking at some graphs and getting some information, or drawing a graph and then pulling off some information once you've drawn it. Okay. So example 1, interpreting a graph. Each point on the graph represents a person. Explain your answer to each of the following questions. So here we have a graph of the ages and heights of different people. On our horizontal axis, or our independent variable axis, or our domain axis, we have age in years. So there's a label with units, as well as a scale. A scale is however we've divided our graph up, and those scales will fluctuate and change from graph to graph and information to information. On our dependent variable scale, or our y-axis, or our vertical axis, okay, this is or our range axis, a whole bunch of different terms there. Again, we have a title and units, so height in centimeters, and again a scale that's representative of the information that we're given. Generally your graphs will start at 0, 0. Most of the time it's a good idea to do that. If you need to change it to something different, just be very careful on how you lay it out, and if you have questions about it, please ask. Okay, so we're going to look at some questions revolving around this graph. Question A says, which person is the oldest and what is her age? His or her age. Oldest, so we look at age, we find out who the oldest or where the oldest person would happen to be, and that would be way over to the right, wherever the furthest one to the right is. And we can see that it is at G here, and G would be about how old. Remember to make sure that you look at your scale, how the numbers are divided for each box. Each box here I know is representative of 2, so it goes 0, 2, 4, 6, 8, 10, 12, 14, 16. This would be 18, okay? Not 17 like you might think, or 19, one less than 20, but 18 because each of the boxes is 2. So that person is person G, and he or she would be 18 years old. Okay. Question B. Which person is the youngest and what is his or her age? Youngest would be the furthest to the left this way. Whoops, eraser, furthest to the left this way. And in this case we have, actually we could call it a 0 because it's what that would be. And that would be considered a newborn. Hasn't quite reached their first birthday yet, so we refer to their age in months. Normally, this would be person A, whoever it happens to be. They would be 0, and we would know this as a newborn, or a newborn baby. Question C. Which two people have the same height? So again, you look at the other axis, this time height, and we're looking for two that have the same height. So here's 50, whoops, eraser. Here is, I'm going to fatten this up a little bit actually. Here is 50, nobody else. Here is 100. Oh, B and C are both the same height. D, nobody. F, nobody. E, nobody. G, nobody. So it's going to be persons C and B, or B and C. Okay. B and C. And what is that height? Well, that value is 100. 100 what? Centimeters. Question D, which two people have the same age and what is this age? So this time we're looking at the age axis. Nobody is A, nobody's B, nobody's C. Two people are D and E, nobody's F and nobody's G. I mean, no pairs, I mean, so we just have D and E. Two people have the same height, D and E. And what is this age, not height, age, I mean, and that age would be, what's this value here? If I blow this up a little bit, remember 2, 4, 6, 8. This would be 10, 12, 14, right? So they are 10. Now, if I want to get technical, I would say years old. And 10 years old. Because you should always put the units in if you have the opportunity. Which person of B or C is taller for her age, his or her age? So for persons B or C, who is taller for their age? So B is 100 centimeters and 2 years old, and C is 100 centimeters and 3 years old. So taller for their age would be B. Oops. Person B, 2 years old, 100 centimeters. Question F. Does this graph represent a function? So remember, for a function, we had said that our definition was, let's look back just to make sure, where's our function definition? A function is a special type of relation in which one element in the domain is associated with one element in the range. Means one x, or in our case, one age only gives rise to one height. Okay? And I'll give you a quick prelude on a quick way to figure out whether something is a function or not. So here, here's our graph. A, 0 height gives us 1 age. 2 years old gives us 2 years old gives us 1 height. 3 years old gives us 1 height. 14 years old gives us 1 height. 18 years old gives us 1 height. But right here, 10 years old gives us both 125 centimeters and 150 centimeters, because one domain value gives rise to 2 range values. This is not a function. And that's because at 10 years old, there's both 100 and 125 centimeter heights. Okay, so this is not considered a function. Quick and easy way to know that is something we call the vertical line test. The vertical line test tells us right away if a representation in a graph is or is not a function. If I can draw a vertical line through 2 points of that graph, it is not a function. Ever, 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 ever. Okay. I'll come back in the next video with example number 2.